Right, so Assalamualaikum and hi. So today I would like to build a practical test for fluid monitoring and thermal process in a tank system using a lab view. So I will show you the recording while I explain it a bit. Right, so first thing first, we need to get a prompt user and put two input here, which is the head and the temperature. So the message to display is to select the maximum value. Right. So next we move to the front panel to get the numeric control. We need to get two of them. The first one is for the temperature max, and the second one is for the heat max. Then we move to the block diagram and we need to connect the heat max to the heat and temperature max to the temperature. So for the next step, we move back to the front panel. Then we need to get the tab control on the layout. So we need to rename the page 1 and page 2. So the first page is for the fluid system, and for the second page we need to rename it as a thermal system. So next we need to get the numeric control. We need to get four of them, for four for thermal system and four for the fluid system. So for the first numeric control, we need to name it as a capacitance. The second one is the resistance. The third one is the temperature. Temperature input, and the last one is initial temperature. So next we need to get a thermometer for the thermal system, and we need to add a digital display for it so that it is easier to read the numbers. Then we move to the fluid system. We need to do the same thing, which is we need four numeric control and one tank. So the first box is for the magnitude, and the second one for the initial heat. The third one is for the resistance, and the final one is for the capacitance. So next we need to get a tank. So go to the classic boolean, go to classic and numeric, and get the classic tank. And we need to do the same thing for tank, which is to get the digital display for it. So right, so we need to get a switch boolean. So we need to rename it as select input type. So the first one is step and the second one is for the impulse. Then we need to group them together so that when we select all of it, will move together. Okay, we need to put in tank, in fluid system, and the second one for the thermal system. So there are two types of it. So now we move to the programming. We need to group them together. So one group is for the fluid system and the other group is for the thermal system. So in the fluid system, we have a magnitude, initial heat, resistance, and the capacitance. While on the thermal system, we have a capacitance, resistance, temperature input, and initial temperature theta. Now we can change them to view as icon or not to save the space. So first thing that we need to do is go to the structure and go to structures and get the case structure. So the first case we need to put the fluid system, and the second case we need to put the thermal system. So you can change the name if the name is wrong. So next we need to get the while loop for the first structures, and inside the while loop we need to get the wait time. Need to get a wait time and set the wait time to 200 millisecond, which is zero point 0.2 second, to control the update rate. So So inside the structure, we need to get another structure, case structure, for this. So we just need to rearrange them like this. So now I'm just going to show you. I'm going to fast forward this and I'm going to show you. Right, so we go to the wiring part. So you need to follow this wiring. So wait, I'm going to show it back. So this is inside the fluid system for true wiring. So the first we need to do, oh, wait. So this wiring is not for the true part. This is for the thermal system. So we need to get the case structure again. And put it back inside the thermal because this equation is for the thermal system. So we just need to rearrange them so that the wiring didn't look messy. But the first one we need to put is the temperature. No, not. Right, so as you can see here that this is the thermal system wiring for true part. Okay, so next I'm going to do is for thermal system also, but on the false part. So I'm going to fast forward it a bit. So as you can see here that the temperature connect to wear, resistance, capacitance, and the initial temperature. You can follow this step to do it. Right, so we have finished the thermal system for true and false case. So now we move to the fluid system. I'm just going to fast forward it for the fluid system. Right, you can see here that I've connected all of this. Right, I've done for the true part on fluid system. Okay. Don't forget to wire the select input type to the case box also. So next we move to the fluid system onto the false case. So I'm just going to fast forward it until it's nearly done. Right, so this is the result for the thermal system false cases. So you can see here that all of these have been connected. Okay, so we have connected for thermal system true and false cases, and for the fluid system true and false cases. So I'm just correcting the line here because I've made fault for this. Okay, so next we need to get a elapsed time and set the elapsed time to 0.2. Next we need to wire the elapsed time second to the wire inside the case that haven't been wired yet. This is thermal system false. So for this, the equation implementation, so it built up the mathematical model for both the steps and impulse input for the fluid and thermal equation with um, thermal equation within their respective cases. So remember to incorporate the time constant, which is time over RC, using the elapsed time function that we got here earlier. So after we have done wiring the elapsed time on both cases, right, we need to get a reset on the elapsed time. So click create. Right. So we got our reset button. So we need to add the reset button on the elapsed time, and we go to the front panel and we can change the reset button. We can replace it with a refresh silver button. We get to right click that and replace. So refresh silver button. And remove the label and then resize it. Right, so now we move to the block diagram again after we have replaced the reset button to the silver one. We move to the block diagram back. Then we need to wire up the tank and the thermometer inside the cases. So you just need to follow what I do. For thermal, we need to link it with the thermometer. For thermometer, and for tank, we need to change it first into the fluid system so that we can link it up. Change to the fluid system and wire the tank inside the cases. For thermometer on the fluid system, we just need to create a constant, and we didn't need to change it, change the number, we just leave it to 0. And for the thermal system, the tank, we also need to create a constant for it, and the number also 0. So next step that we need to do is get structure and flat sequence, and we put the flat sequence cases all on top of them, and right click to add a frame before, and at the back we need to add a frame after also. So inside the frame, the first frame, we need to put the three thing that we do first. The first thing that we do, right? And just right on the third box, you need to resize all of them so that it have spaces. Right. So on the last block, we need to get this VI and need to get this VI and go to the method for VI classes and go to the default value and click on the reinitialize all to default. And then we just need to connect it. Now we need to create a property node and create a value for temperature max and for the heat max. We need to create a value for two of them. Do the same thing, create property nodes and value. Then go to the numeric and get a multiply, get two of them. So the first one, we need to multiply the temperature max with the constant, which we have set to 0.7. Set it to 0.7. So we have to do this part where we get the flat sequence. Wait a minute. So I'm just gonna fast forward it because you can see it clearly. Okay, so here, after we have timed the temperature max and the heat max with constant for both of it, we need to connect it with a greater than temperature. We need to connect it with thermometer, and for the heat max we need to connect it with tank, as you can see here. Right, so next we need to get a string, and this one is select. So we need to get 4 of this. So on the first one, we need to write warning above 70% of max temperature. And for the second one is thermal system. We need to do the same thing also for the tank part, which is warning above 70% of maximum heat. And this one here, we need to change it to the fluid system. Alright, and we just need to connect it. Then here we need to get string and path. Go to string and path and get the string indicator. And just put it there and resize it. Select justify. So now that we get a string, so the last one that we need is the last case is we need one more case. So we get the wire from tab control and connect to the one more case system, a case structure. So first we need to get the select from the fluid system and connect it to the case first. Then from the cases we need to connect it to the string, which will be the output. Then we get the select part for the thermal system and do the same thing. So as you can see there, so the last one that we need to put the stop button. So the program must stop if any of these 4 condition met. So this stop button here will stop the system automatically when we press the stop button. So we didn't need to use the stop button on top of that. This one, we just need to use this stop button for emergency. So now we need to get the compound arithmetic and change the mode to O and connect the heat of temperature max, heat max, and the stop button. So we need to get the greater than, so, and put it to heat max. Temperature max and thermometer, and do the same thing, also get the comparison greater or equal for heat max and the tank. And then we just need to put it to the compound arithmetic. Connect three of them to compound arithmetic. And the result we need to put at the breakpoint there. Right, so for the final step, we need to get the comparison. The first one, we need to connect it to the elapsed time and create a constant and put it to 20,000. And the end of it, we need to connect with the compound arithmetic. So we need to do the same thing with the thermal system and the fluid system. Connect the first one with the elapsed time, and the second one we need to put the constant to 10K. Right, so sorry that I have connected wrongly. Um, So now you can see here that this arrow can be start. So I will show wait. So now there you have it, a complete interactive simulation for monitoring fluid and thermal process in LabVIEW, complete with the user input, visual feedback, and critical safety stop. So I will put the result here. So I think that's all from me. Thank you.